today we're going to be talking about the bubble sort, and more importantly, what is a bubble sort, how it works, and some examples. So let's start off with what a sort is. A sort is when you arrange systematically in groups according to type, class, etc. A lot of the times these are used in integers in programming, such as C++, using vectors and arrays. So let's start off with what a bubble sort is. Well, essentially, we use the word bubbling. If you remember the animation from before, there were bubbles rising to the top. So, coincidentally, a bubble sort uses this idea where elements rise to their proper location. This is done by comparing adjacent elements. So let's start off with a real-life video.
So here's a set of cards I have. They're obviously not in order. And I'm going to use these cards to demonstrate how a bubble sort works. So you're supposed to compare the card you're looking at to the cards adjacent to it. We're going to sort it from least to greatest. So let's start off with the first term, or first card we have, ace, or 1. So we look at the number 3 right next to it. Now we have to see if the ace we have is greater than 3 or less than 3. If it's less than 3, we're going to leave it, and if it's greater than 3, we're going to have to swap. Coincidentally, the ace just happens to be less than 3, so we're going to move on to the 3. Now we have to see if the 3 is less than 3 or less than 5 or greater than 5. Since 3 is less than 5, we leave the cards as is, and we continue on to the next turn. Now we compare the 5 to the 4. Since the 5 is greater than the 4, we have to swap them. And we continue on to the next set of cards. 5 is greater than 2, so we swap these. And now this enables us to have the greatest term in the entire set at the end of the array, or at the end of the list. So we'll just lock this card in, because we know it's going to be the highest card. Now let's continue on with the other cards. These have to start from the beginning of the list again. So once again, A is less than 3, so we're going to move on to the 3. 3 is less than 4, so we're going to move on to the 4. 4 is less than 2. Actually, wait, no. 4 is greater than 2. So we're going to swap the 4 with the 2, and that gives us our second highest term. Now we start at the beginning of the list again. A is less than 3. We continue. 3 is greater than 2, so we swap these. And there you have it.
Now that we've seen that video, let's get on to the code. Here we have a function, or as it's called here, a procedure, bubble sort, and one of its arguments is an array, which would be a list of sortable items. Let's just talk about integers, because those seem to be used mostly. We have a value, n. We have an integer, n, which is equal to the value, the length of a. So if our array had 5 items in it, the length of a would be 5. There you go. Here we have our loop, our main loop, this repeat over here, and it's going to run this batch of code until we have not swapped. So the moment we do not swap is going to be the moment this loop is going to stop, and we're going to end the procedure. Here we have our for loop, and wow, okay. Here we have our for loop, and basically it's going to have an integer I, which is equal to 1, and it's going to count up to the length of a minus 1. In this for loop, each time it runs, it's going to go check at the current item it's looking at. So if ai minus 1 is greater than ai, then. So basically, if the item we're looking at right now is greater than the item next to it, we're going to swap, as seen by here. And then we're going to make the boolean swapped equal to true. And basically we're going to run this each time as long as there's items inside that need to be sorting. So if you remember the cards, we went through it until we got the numbers 1 to 5 in order. Let's continue on to the actual code. Here we have the this snippet of code over here. We're calling in the numbers from a input file, in file, into an array, which is going to start off unordered. Here we have 2 initializations of vectors, unordered array and ordered array. Unordered array is going to be the array we start off with. Ordered array is going to be the array that we're going to end up with. We're going to order the array in order array. You'll see that later on. So we'll have an integer num, which is going to be a placeholder for each number that we're going to pull in from the input file, and we're going to have an integer array val, which is going to count the index of the array we're on. So this while loop, if I find my cursor, oh yeah, this while loop is going to go through the input file as long as there's numbers to be put into the array. So we're gonna uh, put each number into its proper index value into the unordered array, and as that happens, we're gonna increase array value by 1, so we can go on to the next index value. Once we're done that, you're gonna find this ordered array is equal to unordered array. So we're gonna push all the numbers from unordered array into ordered array. These 10,000 numbers are going to be put into ordered array. Let's continue. Oh, the text changed. Here we have a boolean finished is equal to false. If you remember, we used swapped. Here we have integer temporary, which is equal to 0. This is going to be used for our swap. We didn't use the swap function. We just did it inside this snippet of code. Here's our while loop. As long as finished is equal to false, we're going to do this. We're going to run this code. So inside the while loop, we're going to put finish is equal to true, just to make sure there's no glitching. So we're going to have a for loop where int I is equal to 0, I is less than the size minus 1, excuse me. We have to do -1 because the array starts at 0. The index of the array starts at 0. So when we're counting the index, we have to make sure we're getting the right numbers. Otherwise, everything will be off by 1. So in this for loop, we're going to run it how many times there are items inside the for loop. So here we have if ordered array I is greater than ordered array I plus 1, then we're going to have the temporary number is equal to ordered array I. So this is pretty much the swap here. So I'll just run through it quickly. The temp is equal to ordered array I, so the number we're looking at. Ordered array I is going to be equal to ordered array I plus 1. So we're going to replace the current value we're looking at with the next value. And the next value we're looking at will be replaced with the previous value, with the current value we're looking at. So if you remember, it was temp. And then we're going to make finish is equal to false. So once finish is equal to false, we'll go back, it'll send us back here. And it's going to run this through again, and it's going to keep on doing that. It just so happens that if, as long as it's unordered, finish is going to be equal to false. And once it is ordered, this for loop is going to be done, and it's going to say finish is equal to true. So when finish is equal to true, this while loop will no longer work because it's only listening for when finish is equal to false. So it makes it pretty efficient using a while loop. And that's all I have. There we go. Okay, so here is the main CVP file. Let's start from the top. Over here we have our includes. We'll talk about those later on. Not important though. We have fstream_in file, random.txt. That is our file filled with random integers from 1 to 1 million. Absolutely no order. These are the numbers that we need to sort. But this is the file that the program is going to read. This is the out file. This is the file that the program is going to create, and it's going to sort all of them. Over here we have our if statement. If we're not able to create a file or read the file, it would result in an error. That's okay. Over here we have a while loop reading into the file, and yeah. Over here we have the sort. You've already seen that. And over here we have the program writing into the out file. So let's just run the program to see how to get a demo. It'll take some time because it needs to create the file. And there you go, 6 seconds approximately. Now let's open up the sorted file. As you can see, this popped up here. And sorted. Awesome.